So, what's the one skill that really separates a good developer from a great one? It's not just about writing perfect code, it's about seeing the bigger picture. It's the ability to design a system that can go from just a handful of users to millions without breaking a sweat. Today, we're going to walk through that journey step by step.
Yeah, really think about it. How does an app like TikTok or Instagram handle millions of people all tapping and scrolling at the exact same time? How does it not just fall over? Well, the answer is a masterclass in something called system design.
And the secret, believe it or not, isn't some massive, blinking supercomputer tucked away in a basement. It's a journey. And it's a journey that starts from the most humble of beginnings, just a single server. By building up from there, we can really see how all the pieces fit together. So let's start at square one.
Okay, so here we are at the very beginning, the simplest possible setup. One user, one server. Let's picture a brand new blog or maybe a small side project. At this stage, a single machine can pretty much handle everything we need it to do. The whole process is really straightforward. A web browser sends a request to our server. And that one server, man, it's doing everything. It's running the application logic, it's talking to its own database, and it's sending a response right back. It's simple, it's effective, and for a small number of users, it's perfect. But it's not going to stay this simple for long.
Sooner or later, if things go well, our app starts to get popular. And that's when we hit our first major roadblock. That single server, the one that used to be our hero, well, now it's trying to do way too much.
The server is basically trying to be the chef and the waiter at the same time. It's constantly switching between running the app and digging through the database. This creates a huge performance bottleneck. As more and more people use the app, everything gets slower and slower until the whole system just grinds to a halt.
So here's our first big architectural move. We split the work. We give the application its own dedicated server, and we give the database its own dedicated server. Now we can tune and scale each one of them independently based on what it needs. This is a total game changer.
Now that our database has its own home, we have a really important choice to make: SQL or no SQL. Think of SQL as a super organized spreadsheet. Everything has a place with neat rows and columns. It's perfect for structured data where consistency is everything, like a banking app. No SQL, on the other hand, is more like a flexible folder of documents. It's built for speed and handling massive amounts of less structured data, like what a recommendation engine needs. The right choice here completely depends on the job at hand.
All right, we fixed the data bottleneck, but our own success has just revealed the next problem. All that new traffic is now flooding our one application server, and it's become the new weak link in the chain.
Our app is a certified hit, which is great, except now our single web server is just getting hammered. Pages are loading slowly, people are getting errors. It's clear that one server just isn't going to cut it anymore. It's time to share the load. So we're at a crossroads with two main options. We could scale up, which just means buying a bigger, more powerful server. It's simple, but eventually we're going to hit a ceiling. There's only so big a server can get. The smarter, long-term move is to scale out. Instead of one big server, we use lots of smaller ones. This is way more flexible, it's basically infinitely scalable, and it's fault-tolerant. If one server goes down, the others just pick up the slack.
So, how do we manage all these new servers? We do it with a load balancer. The best way to think of this thing is as the ultimate traffic cop for our system. It sits right at the front, and as every request comes in, it directs it to the server that's least busy. It ensures a nice, smooth flow of traffic and prevents any single server from getting totally overwhelmed. Okay, let's take a look at what we've built. It's getting a little more complex now, right? We have multiple app servers, a database server, a load balancer, but how do all of these different parts talk to each other without it turning into complete chaos? We need a universal language.
And this is a really big deal. Without some kind of common language, our system would just fall apart. We need a clear set of rules, a contract that every single component agrees to follow.
And that contract is the API, the Application Programming Interface. The restaurant menu analogy is perfect. The menu tells a customer exactly what they can order and what they can expect to get, but they don't need to know anything about how the kitchen is actually making the food. An API does exactly that, but for software.
This API contract is like a superpower for the development team. It creates these really clear boundaries. It lets different teams work on their own parts of the system without tripping over each other. It hides all the messy internal details and just presents a clean, simple, and predictable interface to everything else.
So,
Our system is now scalable and it's well-structured. It's humming along nicely. But there's one last and absolutely critical piece of the puzzle we have to talk about: security.
Security really boils down to two fundamental questions. The first one is authentication, and it asks, who are you? This is about verifying an identity, with a username and password. Once we know who someone is, the second question kicks in: authorization. This one asks, okay, what are they allowed to do? This is all about permissions. Is this person just a viewer who can read things, or are they an admin who can actually change things?
What a journey, right? Let's do a quick recap. We started with just one server doing everything. Then we split out the database to handle the data load. We beat the traffic flood by scaling out with more servers and a load balancer. We got everyone speaking the same language with APIs, and finally, we secured the whole thing with authentication and authorization. We've actually built something that's truly scalable.
So, we've built this robust system that's ready to serve millions. But the thing about system design is that the journey never really ends. With every solution, a brand new challenge, a new bottleneck usually appears. So, what's next? Maybe the database starts getting slow again, which could lead us to caching. Or maybe users on the other side of the world are seeing delays, which might point us toward a content delivery network. That is a question for another time.